now we'll be going to different topic. Here also like algorithms are used, but it is not like the supervised or unsupervised. Okay, where you will be using both in supervised and unsupervised these kind of things. So that is called as, we are putting in the main heading dimensionality reduction. So from the main heading dimensionality reduction, what do you understand? What could be this? Just give me a second. Yeah, sorry, it was a phone call. Okay, so anybody could guess what is this all about? I mean, the dimensionality reduction. Okay, I'll tell you. So this dimensional reduction is a process of, so from the name itself, we are understanding there is something called reduction. So it's a process of reducing the number of random variables under consideration by obtaining a set of principal variables. Okay, so this, I mean, we have I mean, any data set you take, we have so many features in the sense we have so many columns, right? So I mean, half of the columns won't be of any use. It will be like, we get some data, we just put it. Okay, we just get the raw data from somewhere, and we have so many features will be there. So we have to identify which features can be deleted or reduced in order to have something, so that you could get accurate values. Okay, you can measure it accurately, you can build an algorithm where you would get a possible, I mean, outcomes for some use, some specific purpose you'll be getting. So for that it is very necessary for, so here in machine learning classification programs, there are often too many factors on the basis of which the final classification is done. These factors are basically variables called features. The higher the number of features, the harder it gets to visualize the training set and then work on it. Sometimes most of these features are correlated and hence redundant. This is where the dimensionality reduction algorithms come into play. So whenever there are more number of features, your dimensionality reduction comes to play. Okay. So because you can't take that much of features, you can't actually fit into the algorithm. Okay. So any algorithm you take, you will be fitting it, right? You fitting into the, even if it, you would remember, those who had done the Python programming, you would have done the command like fit, right? So any algorithm you will be fitting into it. But what happens when the features, it's not like lot of features, in the features which are not important is there, it becomes an overfitting, meaning you won't get the actual outcome which you need, because we don't do any sense. Okay, you need not fit all those data. It would be kind of like that. So this thing is mainly divided into feature selection and feature extraction. So this dimensionality reduction we are mainly seeing in two groups, known as feature selection and feature extraction. Okay, so now here, so this is a diagram. I mean, this is how the feature selection would work actually. So you will be having useful data and you will be having some noise, and from this you will be selecting the useful data alone, and then you will be doing the analysis. In the analysis in this, you have to check which algorithm to be used, and accordingly you will be getting the outputs. Okay. So now next, this feature selection. So feature selection, so it will be easier for you people when you look at this diagram. So here I'm going to purchase a second-hand car. Okay. So now here the model of the car is there, year is there, miles is there, and owner name is there. So when I want to purchase this, I mean, I am going to check the model, year, and miles. I'm not going to check the owner's name. Okay. It is not going to give me any useful information. Okay. I'm not going to do anything with the owner's name. Okay. So I can reduce it. Okay. This is what called as this dimensionality reduction, and in that we are calling one type as feature selection. So this feature selection is a method aims to find a subset of the input variables that are most relevant from the original data set. Okay, so here so many strategies they use like filter, wrapper, embedded, but the main thing is that you will be taking out or reducing the unwanted variables or the features. Okay, so here they are telling everything as variables. So the variables in the sense the features which are unwanted you will be deleting or reducing. Okay, so that is how this feature selection is done. So now here, so when you check the feature selection, so there are, I mean, depending upon the input variable and output variable, you have different feature selection models. Okay, so now here when you are going very much deep into the data analysis, you will be studying about all those things. Okay, so how to check how this input and data variable, input and output variable. I mean, the relation between them and how you will be taking out that you will be studying in detail when you go through deeply in this data science. Okay. So now when you look at the variables, so variables are like mainly of two categories. Okay. Numerical variables and the categorical variables. So when I say numerical variables, it includes the integers, floats, and number. Okay. So you know, right, what is integer, what is float, and what is numbers. What is float?
Decimal values 1, 2, or 3.
Sorry, I couldn't hear. I mean, you are some disturbance there.
No, ma'am, not the
Okay, fine. So the float is that the decimal values will be there, right? So all these are float is like point, all these things. Numbers in the sense any numbers. Integers you'll be having minus value, plus one. All these things are numerical values, numerical variables. Now when you come to this categorical variables, so this include the labels, strings, booleans, etc. So here categorical is where you will be having even the strings, that's the characters. Okay, that is yes, no, all these are like strings, no, the boolean variables. All this comes into the categorical variables. That is we will denote it as category. It belongs to one category or the other category. So those are called as categorical variables. This is main classification of variables. There are like so many variable classification you'll be going through. So here in this mainly they are depending upon the numerical categorical, they will be using this feature selection model. So now here you have like set of feature selection models. Okay, so now here you have Pearson correlation, Spearman rank correlation. Like if both the input variable and output variable are numerical, we are using this. Now if the numerical is input, and then if the output is categorical, we are using ANOVA. So just, I mean, if you get time, just go through all those things, all these things you go through, because sorry, so because it will be useful for you when you go for some interviews, or like if you are very sure that you are going into the data science domain, then you should definitely go through all these stuffs. Okay, so now here this input variable, if it is categorical and if the output variable is numerical, we are using the Kendall's rank coefficient. So all these are like different. It's not now very much important for you like when you are just studying, but then when you are when you are going for the job, then you have to go through all these steps. So now here if you see all these things, there is something called correlation. Okay, so you remember the name correlation, so you should understand what correlation is that. Okay, so in every place you will be using the correlation. So today you have to check. I mean, some of the terminologies I will be introducing today. So your work for today would be like you have to check all those terminologies and come tomorrow, because I'll be using those terminologies again and again. Okay, so you should be thorough with all those things. Okay, I'll try to give some, if I could find some simple example, I'll try to give. Otherwise, it's quite like tedious that you can't finish it in one class. Okay, so because like in this week we are completing, right? So now you have to check all these terminologies, okay? Whichever I am telling at the end of the class. So now next is, so here you remember the word correlation, we'll come to that part. And now here what we saw is feature selection. Okay, so feature selection, we are just taking out, I mean taking out the unwanted features. Okay, we are just keeping the most relevant features. Okay, that is what feature selection is. Now next one is feature extraction. Okay, so feature extraction is it converts the data from high dimensional space to one with lesser dimension. And it can be linear or non-linear. So this technique finds a smaller set of new variables, each of which is a combination of input variable. So what happens over here is like, so I have some 10 set of features. Okay, 10 set of features I am having. So what I will do is I will take another set. Okay, a new set I will take, a new feature I will add, such that some 2 or 3 features I will combine and I will give the new feature. So that now like 3 features, if I'm taking from the 10 features, I'm taking 3 features out. Okay, so then I'll be having only 7. Okay, so like that I'll be reducing like some features in that group, in that large data set, I'll be converting to one feature. Okay, all the information from those features will be there in this. Okay, in that one feature which I'm converting. Okay, only thing is that we are just transforming. Okay, we are transforming. That is what we said is from high dimensional to low dimensional, lesser dimensions, we are transforming. Okay, it's not like actually reducing. All the information is there, but still it looks like in reducing, because from 10 features to I am converting to 7 features. That is
Ma'am, can you give an example?
example.
Like if the data are given like age and height and weight, then how will you combine all of three into one?
No, not 8 5, not like that. Okay, I'll try to find some example if possible by tomorrow. I couldn't think about any example by now. Mm. I'll be giving a value. So now if it is like, now if I am saying that height and weight. So now height and weight, I know that mostly these two variables will be interlinked with each other. Okay, this height and weight. So now what I will do is this height and weight, I will find out a certain variable of relation between both of them. Okay, so now the variability or the how with a certain relation, a correlation factor or something, I'll find both of between both of them, and I will add as a new feature for, so that I will be excluding these both. This happens when a large where so many features are there. I will take 2 features. I will take those values and I will find a relation between them, and then I'll put it as a separate feature. Okay, so that is how the feature extraction happens. So if any real-time example is there, I'll try to find it out. If anything is simple, I'll just try to find it out for you. So here this feature extraction is where, and we'll be looking only about the principal component analysis. Okay, so there are so many feature extraction algorithms are there. So like principal component analysis, linear discriminant analysis, and then generalized discriminant analysis. Okay, so many like feature extraction algorithms are there. So in all these algorithms, you will be transforming from the higher dimension to the lower. Okay, so the mainly you will be using principal component analysis, and that is mostly used in everything, all the algorithms. So we'll be looking about principal component analysis tomorrow. And next, the first, I mean, when we were seeing this, right? So we were having this correlation everywhere. So now we are going to just see what is correlation. Okay, so now the correlation is a quantity measuring the extent of the interdependence of variable quantities. Okay, so it is like now I have two variables. Then the correlation is the factor which gives how much, or the measure a measure of how much it is dependence, these variables. Okay, so here this correlation have coefficient as like Pearson coefficient, linear coefficient, sample, population. So many varieties of correlation is there, but it's just a measure of interdependence of variable quantities. Okay, so this is like when I have, so now we learned about linear regression, right? So now before I am going to the linear regression, what I can do is I can find the correlation. Now suppose I have so many input, like so many features are there. Okay, so many features are there, and then I have an output feature is there. So now what I will do is, in the input features, each input feature with the output feature, I will find out the correlation value. Okay, how much it is interdependence is there, I'll find it out. If there is no correlation, okay, if I'm not finding any relationship between on a feature and the output, like input feature and the output feature, then I can exclude that input feature, considering it's like an outlier or it will be overfitting to the model. This is one way of like doing the feature selection. Okay, so I can exclude something which is not having much correlation. Meaning of that the input variable is not correlated to the output variable, is like it is not much related or not much dependent upon the output variable, so that I can take it out. After taking it out, I can do my linear regression. Okay, so this correlation factor, this correlation thing will be coming on, okay, all through your algorithms. This correlation name would be coming. So this correlation coefficient, so this measure, so now the quantity measuring this extent of interdependence is like that. This measurement is known as correlation coefficient. So this correlation coefficient is usually represented using the symbol R, and it ranges from -1 to 1. Okay, so this range would be like -1 to 1. This correlation coefficient quite close to 0. So for positive, when it is quite close to 0, then we can simply say there is no relationship between the two variables. So if it is 0, mostly you won't be getting it as 0. You will be getting like 0.1 or like -0.1, something like that. Okay, so like 0.8, whatever it is. So when it is closer to 0, we will be considering there won't be any relationship between the variables. Now, if the correlation coefficient is close to +1, means there is a positive relationship. Okay, so what is positive relationship is, it is like the proportionality. All of you would have studied about the proportionality, right? Like one variable, if it is increasing, the other variable will also increase. Okay, so that is positive relationship. One variable increasing and the other variable will also increase. Okay, that is the positive relationship or positive correlation coefficient. Like if you are getting close to +1, okay, so like 0.9 or something, you will be having the positive relationship. Meaning is that is the proportional relationship. That means one change in one variable affects the change in other variable. Okay, so now next is the -1. So this, when the correlation coefficient is -1, it's close to -1, it indicates a negative relationship. Okay, so negative relationship, that means it's the inverse proportional. Okay, so this all you have learned in physics, no? This proportional and inverse proportional. So this inverse proportional meaning is that with an increase in one variable, the other variable decreases. If one variable increases, the other variable decreases, or vice versa. When one variable decreases, the other variable increases. Okay, so that is how this is. Okay, so you are getting right. So the correlation coefficient is 0 There won't be any relationship. When it is 1, you have a proportional relationship, that is positive relationship. And when it is minus 1, you have a negative relationship or an inverse proportionality. Okay, so this is all about correlation. So now here, like this, as I said, that a linear regression. So all of you know, like this is like, if I'm not this is called as a scatter plot. Okay, this scatter plot is where this these dots are there. You will be having x-axis, y-axis, and some dots all here and there. So this is known as scatter plot. So this dots are nothing but a x comma y. Okay, so we are just pointing all the variable, I mean data I'm having as x comma y. Okay, so that all I'll be marking as a dots. Okay, so now here, when there is a strong positive correlation, what happens is I'll be getting the linear line like this. Okay, this that is the that is a dependence, or that is a strong relationship between the variables. Okay, so this is how it will be. Now when it is weak, okay, so it will be more scattered. Okay, so when it is negative, then you will be having the negative line like this. Okay, so this is how the correlation works. Okay, so when you have a strong, I mean when you have positive or negative, there is relationship between the variables is strong. Okay, only thing is that proportionality changes. Okay, only when it is like 0, then it will be scattered so much. Okay, so when it is like completely 0, you'll be having the no correlation. That will be like you can't relate at all. The last scatter plot states that you can't relate at all because the correlation is 0. Okay, there won't be any relationship at all. Now next thing is that covariance. Okay, so now this correlation, covariance, so both are like similar, yet there is some little differences there. Okay, so now both terms you have to keep it in mind. Okay, so this covariance measures how the two variables move with respect to each other, and is an extension of the concept of variance. So you all know about this variance, right? What do you know? What do you mean by variance?
Ma'am, it is a measurement of spread between 2 points. Like,
Okay, okay, I'm not unable to hear you properly, but okay, fine. So this variance is how much it is varying from the mean. So any variable, how much it is varying from the mean, that is what we, how much of this variability is there. So that is what we call it as variance. So it is more about this varying. So here this variance is about a single variable, how much a single variable is varying. But in covariance, how much the variables are varying together. Okay, that is the covariance. So here the value takes from minus infinity to infinity, whereas over there in correlation it is minus 1 to 1. Here it can take from minus infinity to infinity. The higher this value, the more dependent the relationship is. A positive number signifies positive covariance and denotes there is direct relationship. So the as you go with the covariance, if it is more, you will be having a like higher relationship. Effectively, this means that an increase in one variable would also lead to a corresponding increase in other variable. On the other hand, a negative number signifies negative covariance, which denotes an inverse relationship between the two variables. The covariance is perfect for defining the type of relationship. It is bad for interpreting its magnitude. Okay, so this covariance is like for the type of relationship. Okay, it is between the two variables. Okay, so now you just look at the difference between the covariance and the correlation. So almost both are same. Okay, so but then you should find you should keep it in mind the little differences what you have. So it is the measure, covariance is a measure to show the extent to which given two random variables change with respect to each other. Correlation is a measure used to describe how strongly the given two variables are related to each other. Okay, so now here how it is changing. Covariance is how the variables are changing with respect to each other, and correlation will be like how the variables are related with each other. Okay, almost the same, but then this is together how they are varying, and this is like how they are related to each other. Okay, so now then covariance is a measure of correlation, and correlation will be a scale form of covariance. So this, if you try to do any problems, you would be knowing how this both are related to each other. Okay, so now next is this and this already I told you, this covariance lies between minus infinity to infinity, and this correlation lies between -1 and +1. Here, covariance indicates direction of linear relationship between the given two variables. It measures the direction, correlation measures the direction and strength of the linear relationship between the given two variables. So here in covariance, the direction is the main thing given over there. But in correlation, you can have the strength or magnitude also between the two variables. Okay, so this covariance and correlation almost in all the problems, like when there are a lot of features are there, you will be using this. Okay, so just keep it in mind, this covariance, you won't use as such covariance, but you will be coming across a term like a covariance matrix. Okay, so that you will be using whenever there is like now PCA, like principal component analysis or any other feature extraction is there. Most probably you will be using the term covariance matrix. Okay, so that is why I had taken this to just explain this terms. Okay, so the covariance is a measure to show the extent to which the variables change with respect to each other, and correlation is like how they are related to each other. Okay, so just keep that in mind. Almost it looks similar, there is a little difference between both. Okay, so now here today's task for you would be like, so just I will write down in the chat box. Okay, so tomorrow we'll be seeing about this PCA, so you have to look about this eigenvalues. Okay, have you ever heard about this eigenvalues? Just go through this. Okay, eigenvalues, eigenvectors, matrix. So those of you not from this maths like engineering background, so you should definitely go through all these things: eigenvalues, eigenvectors, matrix, and whatever I told you. One second. Matrix, and then correlation, covariance. Okay, this correlation and covariance, what I am stating over here is that not just the definition. You have to go check the formula, and then you have to try it to do it. Okay, then only then you will be getting an idea of what it is. This correlation, covariance, and then in matrix, transpose. Have you heard about all these things? How you do this transpose? All these
Yes,
things
ma'am.
you have heard. Okay, so these all again you should go through, because all these terms, it would be coming in between. So this matrix, correlation, covariation, eigenvalues, eigenvectors, so it will be coming over there when we are going to the next part, no, when the PCA. So I'll be telling all these things, so it will be very vague for you, like if you don't know about all these things. So just go through all these things, like just see the worked example for this, not just going through. See the worked example of this and understand what is this eigenvalues, eigenvectors, matrix. Come to the matrix and then go for this covariance matrix. Okay, so once you know about the matrix, then you will be knowing what is covariance matrix. Covariance covariance matrix. Okay, so these are all the important things. Okay, so like we'll be using all these things for the we'll be using all these things for tomorrow's class. So just go through all these things when you come, otherwise it will be like I'll try to take some simple examples if possible, but otherwise it will be like quite tedious for you people to understand. So just go through all this stuff with the worked out example. You all got it right? So in today's class, anyone have any doubt?
No, ma'am.
No, ma'am.
Okay, so all of you understand, right? This covariance, correlation, and then dimensionality reduction. So dimensionality reduction, remember, you are taking out the noise from the data so that you will be having only the useful data. So here you have feature selection and feature extraction. So feature selection is like you will be taking now the example I had given, model, year and miles for a car, as well as the owner name for a car is given. But then we are not going to do anything with the owner's name. Okay, so now so I can easily delete it off. So that is like I can select only the model, year and miles. Okay, so that is feature selection in the dimensionality reduction. Okay, so now you have feature extraction. So feature extraction is like you will be having so many features. When there are too many features, I'll try to combine two or three features together. Okay, so I'll try to combine two or three features together to make it like a reduction, but actually I'm not reducing. I'll be having all the information available. Okay, so it's like from the higher dimensionality I'm going to the lower dimensionality. So and then you have this variables are of main two types, categorical and numerical. Numericals where all about the numbers are included with decimals or without decimals, all these things. Categorical will be about the booleans. Mainly it will be like yes or no. That is where the strings are involved. Okay, so depending upon that, you have so many algorithms in used. And in algorithms, when I say for all these things, you will be using this correlation, covariance, all these stuffs. Okay, so you should know what is correlation and covariance. Okay, so now correlation and covariance, when you take it, so here in correlation and covariance, it would be like almost similar. The main difference will be there in covariance. It is from minus infinity to infinity. The value would be from minus infinity to infinity, and correlation, the value would be from minus 1 to 1. Okay, and then here in covariance, it is like the extent to which the given two variables change with respect to each other. That is how it varies with respect to each other. Okay, and in correlation, it is like how describe how strongly the given two random variables are related to each other. It is, this is how it changes and this is how it relates. Okay, so this is the main thing about the difference between covariance and correlation. Okay, so don't forget, like otherwise you won't be understanding anything of what I'm taking tomorrow. So now, like, so just go through covariance matrix, then how to do the transposon matrix, all those, and then eigenvalues, eigenvectors. So all this you just check the worked out examples. Okay, and you try to work out. So today, anyways, you don't have any coding part, right? So just try to work out all these examples and come for tomorrow's class. Okay, is it okay, right?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay, okay, that's all for today. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Welcome.
Thank you, ma'am.